Hello, today we're going to talk about percent composition, and percent composition is the percentage of mass of each element within a compound. For example, if I take a compound C3H8, which would be named by the method that you learned last semester, that would be tricarbon octahydride. However, the common name, if you were to look this up, which is named by an organic nomenclature system that we're not going to learn in this class, but if you look this up, this is going to be called propane. Okay, so percent composition would be, so for example, if I had 1 kilogram of this propane or tricarbon octahydride, what mass or what percentage of that mass would be carbon and what percentage of that mass would be hydrogen. And that's what percent composition tells us. And so I'm going to show you quickly how to calculate that. I'm going to show you a system to kind of organize it to help you keep track of what you're calculating and not get lost in the calculation. Now, many of you will probably choose not to use this system, but it will help you. So I'm going to show you how to do that. So basically you want to start out with first just making kind of a list of the elements that are in there. In this case it's only 2, so it'll be carbon and hydrogen. And then we're going to look at the molar mass off the periodic table of each of these. So carbon is going to be 12.01 grams per mole. Hydrogen is going to be 1.008 grams per mole. All right, in this case, then you look at the subscript to see, okay, how many carbons, how many hydrogens do I have? In this case, you have 3 carbons and you have 8 hydrogens. And of course you can multiply this out and you can get the molar mass of each individual element in there. And if I add these two up, I get my total molar mass. You guys have done this in the past, so you know how to do this. But I'm going to lay it out this way because this helps me with my overall calculation. So the percentage basically just tells me what percentage of this molar mass is the carbon and what percentage of it is the hydrogen. And you do this like you do most any percentage. I'll just divide this by my 44.094 grams per mole. Same thing here. And you'll notice that your units basically cancel, and what you wind up with is a unitless number. And we would call this number like a fraction, a fractional, not the same thing as a percentage, but the decimal form of your percentage. So if I put that in my calculator, I'm going to get 0.8171 for my carbon and 0.1829 for my hydrogen. And if you were to add these two numbers together, you should get back to 1 total. Now, if I want to make this an actual percentage, which in most cases we will want to do that, and you just multiply each one by 100% to get my actual total or percentage in the format that you're more used to seeing. And of course, if you add these up now, they should add up to 100%. Now, if you'll follow kind of the system that is laid out here, then it will be easy for you to keep track of what's going on, not get lost in the calculation. With only 2 elements, it's really not that big of a deal. But when we do more elements, I'm going to do a little more complex one for you to see. Then you'll notice that it's better to just keep track of it in a very organized way. Plus, another thing to your advantage is it helps me when I grade it. I can really see what you're doing, and if you make a mistake, then it helps me to be able to give you partial credit because I can tell where you went wrong and what you understood and what you did not understand. When you just put a bunch of scrambled numbers everywhere and then just pop up with an answer at the end, if that answer is incorrect, it's hard for me to give you partial credit because I can't really tell where you went wrong if I can't see this kind of the system that you used to get to the number that you got. All right, let's do a little more of a complex one to show you something that's a little bit more difficult. And this time I'll start with a name and go backwards. So I'll do copper 2 sulfate. And we'll make that a pentahydrate because that's actually a very common form of copper sulfate. So if you remember, this 2 designates, this is an ionic compound, copper sulfate, metal, and then a polyatomic ion. So the 2 designates the charge of the copper, so we know it's going to be 2 plus. Now you don't actually include that in the structure that you write. I'm not putting it there just so you can see it visually. And then my sulfate, if you remember your polyatomic ions, is SO4 2 minus. So here I have a 2 plus, 2 minus, so 1-to-1 ratio should work out just fine. And of course you don't write the 2 minus in there because when you're done, this whole thing is neutral. It would just be written just like this, copper sulfate. All right, now what do I do with this? We talked about this a little bit last semester, but I want to kind of review and show you what to do with this. What this means is that every copper sulfate actually has 5 waters that are surrounding it or kind of attached to it, not bonded like a covalent or an ionic bond, but just kind of attracted around this copper sulfate. So you put a little dot here, looks kind of like a multiplication sign, but it's not really a multiplication sign. And then it's going to have 5 waters. So that would be copper sulfate, copper 2 sulfate, pentahydrate. Now, let's do a percent composition for this. And in this case, you've got more elements. And so I'm just going to list the elements: copper, sulfur, oxygen, hydrogen. Okay, so in this case, only one copper. Well, let me get the molar masses first. Make it a little bit neater there. All right. Of course, only one of these. Only one of these. Oxygen, a little bit more complex. We've got 4 here, and well, we've got 1 here. Well, each water has 1, but we have 5 waters. So I have a total of 5 oxygens over here, 4 here. So 5 plus 4 is 9. Okay, now what about hydrogen? Here I got 2 hydrogens in each water, but I have 5 waters. So 5 times 2 is 10. No hydrogen over here. So times 10. So now we multiply this out, and I'm going to go ahead and drop the units because they're getting ready to cancel anyway. And I'm not going to really worry about my significant figures until I get to the end. I'm just going to keep plenty of decimal places. Okay, so if we add all this up, it's going to give you the formula mass or the molar mass of the formula, just like you've calculated many times. Okay, when I multiply these out, of course, if I add all these up, it should all add up to 1, and to convert these to the percentage form that you're more familiar with, let's multiply by 100%. Okay, when I get to the end, in this particular case, I should keep 4 significant figures. If I add all these up, it should add back up to 100%. These have 4 significant figures, whereas these only have 1 significant figure. But they're exact numbers, so we don't have to worry about them. Okay, hopefully that has helped. If you have any questions, as always, please let me know, and I'll try to answer them. Thanks.